And once we get those out, let's have you actually have out your All About Me sheets first and hand those guys up and over, please, as well. This was everybody able to sign in to their calculators? Yes? So? Oh, okay. So we got through these here, is that right? Okay. So last time we got through, it looks like factoring by a GCF. And we got through regular factoring from middle school over here, and we got rid of difference of squares also. Is that right? Yes? Okay. We're going to do, I guess we'll do these ones down here next. So if you can go through and look, the ones on the left are going to show us sort of the pattern that's there. And then we're going to go through and do it on the right, looking at what's on the left. I don't know whether or not they did this with you last year. Go through, and if you're looking at this great big giant expression here, there's 4 terms. That automatically makes it different from the other ones that we worked with when there was a difference of squares pattern. It was a binomial, meaning 2 terms that can't be added together. And the ones up top, a GCF, we always look for in the beginning. But these ones won't have a GCF throughout. I look at those 4 terms, there's nothing besides a 1 I can take out from all of them. The part about this that's a little bit different is we don't have a GCF for all 4. But instead of viewing it as 4 terms, look at it as 2 sets of 2. Look at the first 2 terms. Is there a GCF from just the first 2 terms that are listed out? And the answer should be yes. Hands up when you can tell me what's the GCF from those first 2. Go ahead. A Y. And then when you take that out, you're left with an X plus 2. Next group also has a GCF. Hands up, please, if you can tell me what's the GCF of the blue. Go ahead. A 3. And when you take that out, now you're left with an X plus 2 again. So far, all they did was identify 2 different GCFs. This is still a binomial, which means it's got 2 terms separated by addition or subtraction, but it's got sort of binomials within the binomial. Now looking at what's there, you've got a GCF twice. You can do a GCF a 3rd time. Look at the new binomial that you got after the factoring. Hands up, please, if you can tell me what is the common factor now after you did the 2 smaller GCFs. What can you factor out from both ends of that binomial? An X plus 2. When that gets factored out, it's not there anymore, and it's not there anymore. That leaves you with a Y plus 3 left over. You're left over sort of with whatever those coefficients are and whatever operations between. For some reason, when people show this, they act as though that there's some sort of math magic that's happening, like this swings down and these join up. No, it's not magic at all. You're just doing the greatest common factor 3 times. So let's take a look at the term on the right here and the expression on the right. If we had that, you can't take a GCF out of the whole thing. Nothing besides a 1 goes into all of them. Look at the first 2. Hands up, please, if you can tell me, what is the GCF of the first 2 terms that are listed out? Just the first 2? Go ahead. I can take out a 2x squared. Hands up, please, when you can tell me what binomial now I'm left with when I take that 2x squared out from both of those first 2 terms. Go ahead. We're left with the quantity of 2x plus 1. When you're out of Spry and you want to say parentheses, we say the quantity of. Now, look at the second group, and this is where you've got to make sure you're thinking. There's 2 more terms we haven't taken a GCF out of. There's 2 possible GCFs that you can take out of the 3rd and 4th term. They're the negative 2x minus 1. Who can tell me what one of the two possible GCFs I could take out would be. There's two that are acceptable. We'll go over the one to use in a minute. Go ahead. We could take out a negative one, or what else could you take out? A positive one. Which one is going to be the one that I take out and why? Play it forward 2 steps. Let's see if you can make sense of what we did in the last example.
Negative one, so that both the quantities are the same.
If you take out a negative one, now you're left with that third GCF. If you were to take out the positive one, you wouldn't be wrong, but you wouldn't have the third GCF, and you sort of force a stop. Hands up, please, if you can tell me the two binomials then that our example will factor down into, because we can do our third GCF now. What two binomials will this factor down into? We got 1, 2, 3, 4, 5, 6. What do you want to say?
2x plus 1 times 2x squared minus 1.
There you go, the 2x plus 1, that's your GCF. The 2x squared minus 1 is what's left over from factoring it out. Do we have questions on that one? This is the last one that we're... In all honesty, I still think these ones are going to be the harder of the two. This is a pattern that's new for you. And actually, maybe we'll even list this out on the side. You need to start and be able to recognize, you talked about a difference of squares before. We went over, well, you should have gone over two previously perfect square numbers. You can give me what one of them would be. It's one example of a perfect square number. Who can tell me? 64 is one. What else we got? Yep. 25 is one. What else we got? 36, and so on. You take any number, multiply it by itself, 4, 9, 16, 25, 36, and so on. But that's middle school stuff. The stuff we're going to do now is we're working with a sum or a difference of perfect cubes. And a perfect cube is a number that you arrive at by taking something and multiplying it by itself 3 times. Who can give me, besides 1, the smallest, all right, our first perfect cube, our smallest perfect cube value after 1. 8's a perfect cube value. So maybe on the side underneath down here, we can start listing them out so you get comfortable with them. Our first one up would be 8. What's the next perfect cube that we could go through and arrive at? If you need the calculator, go to it, that's fine. But it's concerning if we don't know how to get there. What do you want to say for next one? 27, that's 3 times 3 times 3 again. Who can tell me what our next one after a 27 would be? 64, that's 4 times 4 times 4. Next one up after that's going to be 5 cubed. What do we get if we take 5 cubed? 125, great. The next one up after that would be 6 cubed, and I think that's 216. 7 cubed, I think, is 343. And so on. But make a listing on there so you can know what those perfect cube numbers are. When you get a perfect cube, a sum or difference, it's going to factor down into a binomial factor and a trinomial factor. The signs going across, if this is addition, will be plus, minus, plus. And the way you get it is to follow this pattern. Notice that that's the A cubed. We'll see it when we're applying it, but the A term that we're talking about is the cube root of what's ever there. Look at our example on the right-hand side. You've got a sum of perfect cubes. What is the cube root of 27n to the third, or what times itself 3 times gives me 27n to the third? Hands up if we can answer that. Close. 3n. Now, when I do these out, will put a small 3m up above. That lets me know that's my A value. Now I go to the right. I've got a 2 there. Or sorry, I've got an 8 there. What is the cube root of the 8 going to be? That's a 2. Now if you're listing this out, give yourself space for a binomial factor and a trinomial factor. So give a set of parentheses that can fit 2 terms and one that can fit 3. And then your signs going across, we can fill in too. It goes plus, minus, plus. So in the binomial between those terms, it's a plus sign. And in the trinomial between the first and second, it's a minus. And then the second and the third, it's a plus. So you've got the structure down. You sort of built the house. Now we got to fill it in. Notice it says A plus B. That's your A, and that's your B. So what's our binomial factor going to be? There you go. That factors down to a 3m plus 2. The trinomial comes from taking the A and squaring it to start. So who can tell me the first of the 3 terms in that trinomial? What do you think we get? Yeah, 1, 2. Close. Close. Don't forget that coefficient here. But you did the right thing. You've got to square it. Take the 3 and the m and square it to get the 9. Now your next sign was what? Plus, so that's a minus. And it tells you to take A times B. So who wants to guess what that middle term is going to be when we're talking about A's and B's? You've listed it out on your paper. Who thinks they can fill in the second term of our trinomial factorization? Perfect. Our second term is, you were right, it's a negative 6m, but it's the negative just because of the negative that was on the outside of the minus that was there. And then to n, you finish with the b squared. So what is our right value squared going to be, or what's the third term in our trinomial? Yeah, 1, 2, 3, 4, 5. I'll give it 4. There we go. Now, when there's a difference of cubes, it's pretty much exactly the same. What's the only difference between the sum of cubes and the difference of cubes? Hands up when you can see that. What's the only difference between these two? There's literally 1. Yeah, and in this case before, if it's plus, it goes plus, minus, plus. If it's minus, it goes minus, plus, plus. Go through right now. Let's see if leave out space for your binomial factor and your trinomial. Give them a try right now on your own, and let's see. You can come up with your binomial and your trinomial. We'll erase it if it's wrong. There's no firing squad if you make a mistake. Hands up if you want to take a stab at that binomial. What do we think the binomial out of those two? Well, I think the binomial tends to be the easier. What do you want to say? There you go. Who can tell me, please, what our trinomial is going to be now? 1, 2, 3, 4, 5. That trinomial that you get at the end should not be factorable anymore. Do we have questions on those? I'll tell you right now, I believe these last two are new for you for Algebra 2. You didn't do those before, correct? Okay. I'm going to guarantee you that that fifth one down, that triple GCF, they call it grouping, that triple GCF will be on your exam 1,000 times over for here, but it definitely is going to be on your Regents exam as well. If you can do it today, literally, we're going to be doing it pretty much at least once a week from now until June. Yes?
So the envelope for the addition, then you go to plus minus plus. What for subtraction line should we?
So all the easy way for me to remember it is these signs match. The binomials are going to have the same signs. And these two are the opposite of whatever next to it, but it always ends with a plus. I mean, that's as close as I can get. There's no reason, I guess. There is reason, but it's a proof. I mean, it's easier just to remember the shortcut.
Do you factor out with the sign? Like when
Yes.
it's negative 64, wouldn't it be negative 4?
So you're approaching it a different way. You would get the same answer, her question was, well, what if I have this, something like this, right? I think the last one was n cubed minus 64. What if you view this instead as n to the third plus negative 2? What would it be? Negative 4 to the third, right? Because then that last question, something like that. If you were to do that out, you'd get the same answer.
Like, I got a different answer because when you multiply -4 and n, wouldn't it be -4n?
Which one are you talking about? Yes, but you would have to do this then as a sum, right? You treated this like a sum going across. So the binomial and the trinomial, the binomial would have a plus in it, and this is minus plus. So your binomial here, you're saying this is n, and this is a -4. So this would then become n minus 4. What did we do wrong? Oh, I think that's how it would look then, right? Because it's n plus the b value, which would be plus -4, which really this is the same as n minus 4. Which
No,
is,
I mean like when it's like the trinomial.
oh, the trinomial down here? Let's see. So you'd have n squared here, and then minus -4n. So the two negatives would make a plus. Okay? And then this at the end would be -4 squared, which is positive 16. Okay? Now, the last one that we're going to, any more questions on this one, by the way? Last ones that we're going to do, these are the ones that I probably will take a different approach to it than maybe you've had in the past. I don't know. You've done some sort of factoring with the lead coefficient other than 1. That did happen. How did they show it to you? Did they have you do it by guessing and trying out different possibilities, or did they have you do some long, convoluted bunch of steps? Or you don't know? Okay. So there's a robot way that you would sort of train somebody to do it if you didn't think that they could do math that well. But you guys can do math pretty good. If you're going to multiply two binomials together, and this is another thing from the middle school that I will do a little bit different. This is like n plus 4 times n plus 5. When you're multiplying this out, do they still show you that rectangle thing to multiply them, or do they show you how to first outer inner last FOIL? Okay, thank you. So maybe we don't have to re-show this. If you were to FOIL this out, that means first outer inner last. If I multiply my first terms, what do I get? Well, I have an n squared. My outside terms, which are these two here, is positive 5n. The inside two terms here are plus 4n. And then the last terms that I get are plus 20. And then you could combine from there. But that's how you go through and check. And by the way, it happens to work out that when you combine all your like terms, a property of this pattern is that the numbers that are here and here will multiply to give you that value. Okay? Well, you're going to do the same thing now, except the lead coefficient isn't a 1. But it's not going to change that much. Looking at what we have, there's going to be two binomials. So list out right now, it's two binomials. We don't know the signs that are in there, but we can try to find them. We're going to need values in the beginning that multiply to whatever that yellow value is. It's a 2m squared. What needs to be in those first positions for me to get a 2m squared? Think about the breakdown of the factoring or the FOILing. What do I need in those two spots to get me a 2m squared? There's really only one way we can get it. I mean, some people will start saying, well, we use fractions. Yes, congratulations, fractions exist, but most of the time we're working with integers. How can I get the 2m squared in the beginning? What would I need? What do I say?
2m.
Perfect. So in the beginning, and you're lucky because 2m squared is, well, 2 is prime. That means it has only itself and 1 as a factor. So there's only one way I could get 2m squared. So I put a 2m and an m in the front because those guys have to multiply to give you the 2m squared that we were looking for. Now, the values that I put in these places here at the end, they need to multiply to give me -3. Is -3 prime? Is it? Yeah. So we know the only factors we can throw in there is a 3 and a 1. But wait a minute. I can't just pick like a 1 and a 3 and throw them in there. I've got to pick a value that when I put it in here, 2 values, that go in these spots. And what do these values have to multiply to again? -3, but they also have to cause something else to happen. When I FOIL this out, or I do the outside and the inside terms, what do they need to give me? -5. So you're going to try, and I don't want this to crush your spirit and self-worth, you probably will do it wrong. But please, we're not going to cry. You can erase and move on. It's math. We just need to find the numbers. But the part that I always find astonishing, you're not going to get it the first time in the beginning. Like, not close. The more you do it, the easier these get. If I'm doing this out, let's try some different values. And if I'm remembering right, what do you have? Is it 2m squared minus 5m minus 3? Okay? So in the beginning, I know those lead values need to be a 2m and an m. Now, you're going to take a guess. Something that goes in these spots has to multiply to give me -3. And then when I FOIL that whole thing out, though, it's got to give me a -5 in the middle. You can give me any attempt. And by the way, bonus point if you're smart enough to know what it is and give us one that doesn't work. Because I don't want it to work on the first try. I want us to actually have a mild struggle and see why it doesn't work as well. Let's try and see if that works. Now, when I do this out, what do the first terms give me? 2m squared. Now I'm going to do the outside terms, and that gives me a plus 6m. What do my inside terms give me? I can stop right now. His answer was very close. Why was it close, but why was it wrong? It's 2 questions in the same one. It's very close, but also wrong. Why? So what do we need to change, do you think, to make it be a -5? Let's change the sign. So even though we were wrong, we were really close to getting it right. So this one should be a -3 here and a +1. Now let's try. You've got 2m squared. Now, the outside terms are -6m and +1m. Did that work? Yes. So how many tries did it take? Yes. Okay. So now I would go over, and the only thing I really need to see on your paper is what the final answer ends up being, which in this case would be 2m plus 1 and m minus 3. Do we have questions on that? All right. Now, this is the part where you're going to see why the sheet took me an hour. I want you right now to turn it over to the front. Now, this is the part where you've got to make sure the directions right now are going to be very, very challenging. You're going to fold this, but not in half. You know on the front there's this line right here? That's what you're going to fold it on. So when you do that, you can see it says on the side, factoring. And now, as you look at that, you're probably going, oh, I get it now, because when I open it up, what's behind the factoring label, or the GCF label? An example of what GCF factoring looks like. One I gave you and one you did yourself. And then, after the fast factoring ones, what do you see tucked behind that? You see all the examples of fast factoring. You see how these break down and what they're called. Now you're probably thinking, all right, I'm going to throw this away. But wait, it gets better. In a moment, you're going to encounter a mild adult situation here. We're using non-safety scissors. Not screw around. You're going to take them. Make sure no one's nearby. You don't want to hurt anyone. Now, ready? There were some people yesterday who started cutting from here over. Why would you not want to cut from the left to the right? Now, you're going to, in a moment, step up, grab a pair of scissors, and cut along these lines now. Ready? So when you're working, if you want to know, what does the GCF look like again? Well, wait a minute. Here. Here. See there? Now, and how many of those are you going to have? There you go. See? Not that bad. Are you responsible enough to handle the scissors, or do I need to hand them out to you? Hand them out to people? All right. Let's come on up. Grab these. We'll give you a couple minutes. Go through, get this cut. The next thing I need you to also do is to have out, actually, get these guys cut first. Get these guys cut first, please. We don't have enough, by the way. Some people aren't going to have them. If you finish, you might want to be a hero and hand it to someone else nearby. Also, one of the things I find very frustrating is you guys don't get like why we go through and factor. We'll be doing this and covering it multiple times during a year, but understand, it's listed out for you on the back. You don't want to cut through anything. You only want to be cutting it so it's got flaps on it and everything's housed together. If you need another one, go ahead and grab one. Help each other out. If you see somebody's going to cut it wrong, we got an extra pair up here. What do you need? Just another note packet? Where's your locker? Right out here or the other side of the school? But let's do this instead. Use this for today. Okay? The other sheets, you can bring it up later today. Okay? Anyone else need some? Scissors? Have your note packets out, please, and keep that to the side. That way, as we're doing them, you can see, hey, which one does this example look like? And if I get to here, can I go a little bit further or not? But this is for you to make sure that we're able to have something if I'm not there and that I don't know what to do, so I can't do anything. It sort of goes away a little bit. Thank you. Any more? Good. Good. Not bad. Did anybody get injured, by the way, from the scissors? Not bad. Congrats. Let's go through and start off, and I hope that we're able to rip through some of these pretty quickly. Take a look, please, at 1A. Hands up, please, when you can tell me what 1A would factor down to. Take a look. What do we think? Example 1. Choice A, what do we think? We think that's going to factor down to. Let's see if we can get 3 or 4 of us. We'll wait for 4. You can tell me what this 1A would factor down to be. We got 1 person, 2, 3, 4. What do you want to say?
9.
Mm-hmm. And the parentheses is quantity of.
Quantity of
Mm-hmm.
C minus 2.
There you go. Not bad. Take a look, please. Let's have you do, we probably don't need to do more like that. Go through right now and do out 2D right now. Go through and do out 2D. Go back. If you need to see another example, you've got ones listed out. Oh, one other thing, I think we just talked about this last time, about next class, the one that we have on Thursday. Someone will be coming in to do, they're going to show you completing the square again. You're going to be on your best behavior and be super nice. Is that okay? Hands up, please, when you can tell me. Let's ask first what the GCF itself is going to do. See if we can get 6 of us who can tell us just what the GCF would be in 2D. We got 1, 2, 3, 4, 5. What do you want to say in the back? Okay, and what's left when that gets factored out? Hands up when you can tell me what we would be left with after that is factored out. Go ahead. All right, hang on. Thanks. So this is what for MN? Good. Questions on that? Is that right? I think so. How about 4, 3? This one's probably going to be, it's a little bit tougher than what you've done before, but actually not by that much. What's the GCF in 3A? Hands up, please, if you can tell me. For 3A, what's our GCF going to be? Hands up when you can tell me the GCF in 3A. Go ahead. X minus 5. So I'm going to factor that out or divide it out. So I write out an X minus 5, and now in parentheses, I have to list out everything that's left when I take that X minus 5 and divide it out or undistribute it. So who can tell me what I would have left if I went through an undistributed? I don't need you to do any simplifying. I just need you to undistribute. X plus 6, and then plus, on the other side, 2x plus 5. Now, that's not going to be your final answer either. Hands up, please, if you can tell me what you want to list out as your final answer. There's another simplification that can be done. You're here, you should be able to see that. Don't overthink it. Don't overthink it. We got 1, 2, 3, 4 of us, 5, 6 of us. What do you want to say? Go ahead.
3x.
And if you go through, this would be 3x plus 11. Questions on that? How about do B right now on your own? Go through and give B a try on your own. I actually think B is easier than A. Give B a try. You're going to look to take out a GCF in this group. Hands up, please, if you can tell me what you think your GCF is going to be in B. A little bit tougher, but I think if you got the other ones, maybe we'll see this one. What can we divide out from both sides of that great big giant binomial? We got 1, 2, 3, 4, 5.
M plus n squared times.
So the GCF is going to be m plus n squared. We can take that out from both, and what's left when you take that out? Close. Each individual term needs to be squared. The sum of squares is not the same as the sum of two terms then squared. Okay? Do we have questions on that one? I guess the last one that I think might be tough, and it's going to be tough for tough for an easy reason if that's a thing. Try out D right now. Try out D. See if you can identify the GCF. Look at the operators and see what we might have after that. Hands up if you can tell me what you think your GCF is going to be. We think our GCF for this group would be 1, 2 of us, 3, 4. And what's left after you take out the quantity P minus 5? How'd you get 4P plus 6? What's it telling you to do? No? Don't do the math just yet. What are you left with just after you take that out? There's our problem. You've got to remember, it's minus both of those. Both of them. See how it's P plus 2, then minus 3P plus 4? These have been factored out now. So now I'm left still out in front. I have a P minus 5. What's left, though? Maybe we can even do that distribution in our head. Distribute out your negative combined like terms. Who can tell me what we would have left after we did that? We got 1, 2 of us, 3, 4, 5. Go ahead. Now, I'm going to tell you this. I still don't think we're done. I'm looking at that. The first factor, I can't go further with. But what about the second one? Who sees something there where you're going, I can't check out just yet? Yeah, you can take out a GCF now of -2. And that's something we didn't see before. So this is going to be equal to -2. This is P minus 5. And this is, what is this, P plus 1 now? After we take out a -2. And by the way, notice this. What values cause this expression to equal 0? You can tell this right away because anything times 0 is 0. So what's a value of P that would cause this expression to have a value of 0? Who can tell me? What's a value of P that will cause all of that to equal 0 when you multiply it out? We got one person who can tell me? This is why we factor. You need to figure out where the zeros of the graph are. What's a value for P that will cause that whole expression to equal 0 when we multiply it out? What do you want to say? 5 works. What's another one? There you go. 5 and -1 cause the whole thing to equal 0. And if you were looking at it from here, you wouldn't be able to tell that. Because you'd have to do, well, whatever this is, this would have to be the negation of it, and so on. Now, it's really only, well, I'll tell you this. Do out right now, please. Try example 5 on your own. Try example 5 on your own. Let's see how much we picked up from earlier today. Go back, flip those tabs over. Let's see where we stand. Looking at that first one up, walk me through. You can tell me what we would do to start off this example. We got 1 so far, 2 of us, 3, 4. What do you think we would do? Would you like to say? Okay, so what are we going to take out from the first two? And what are you left with? Okay, what can you take out from the next two? And what are you left with then? And we're not done yet. Why are we not done? Because you got a third GCF there. What's the third GCF going to be? An x minus y. And what's left when you take that out? There you go. Do we have questions on that one? All right. How about we skip down, please, and try out example. Have you try out 7? One thing also that we need to go through and have happen is, I think, well, when we have class, I tend not to ask for people. It actually creates bias samples. So we randomly call people, but I need to give your actual names, like what you'd like to be called, instead of like what's in there. So, like, let's say your name in the computer is Michael and you go by Mike or something like that. Just let me know what you actually like to be called. And I'm going to apologize now. I am 1,000% owning. I am horrible with names. I'm in like I actually got tested 2 years ago. I am in the 11th percentile for short-term memory, and I am in the 3rd percentile for name association, which means I remember names as good as 3% of society as a whole. Good. So please understand if I say the wrong name or I mispronounce it. You can judge all you want. But I'll call you up by rows, one at a time. So what we'll do is example, say row 1, come up and you tell me your names, and if it's good, say I'm good. If it's not, my name's Michael on there, I go by Mike, or you spelled my name wrong, or my name's not on there. Do we have, what would we do for 7 to start? What can we do to begin 7?
Factor of the 6x.
And when I take that out, what are you left with?
A plus 2b.
And what about from the next group? What can we factor out from the second two? Keep going. And you're left with?
A plus 2b.
And when you put that together, the A plus 2B is your GCF. What remains is a 6x plus 1. Questions on that one? Yep. You can. And look what it says for the next one. If you get stuck and you can't do grouping as it is, do you have to keep the terms in that order? Do you maybe need to try a different order sometime? Now, if only the directions in example 8 would strongly give you a hint that it's maybe not going to factor as it's currently written, but can if you rearrange it. Give that a try. Try shuffling those terms, see if you can make a GCF happen. And let's have the first row come on up, please. Lauren? Yeah. Okay. Is that what you go by? Yeah. Spelled right? Mm-hmm. Which one are you? Emma. Emma? Is that spelled right? Yes. Go by Emma? Mm-hmm. Okay.
Holly.
Holly? Where are you? Is that spelled right? Mm-hmm. Okay, thank you.
My name is Alexandria.
Okay. Is that what you go by?
Yeah.
Okay, what do you go by? Lexi? There you go. Thank you. Okay. Dylan. Okay. Go by Dylan?
Yeah. Jaden?
Jaden? You go by Jaden?
Yep.
Perfect. All right. Second row, come on up. Jaden. Oh. What's your name?
Brandon.
Brandon. Is that what you go by?
Yep.
Okay. Thank you. Alex. Where are you? Do you see your name on here? I'm missing it. What's your last name?
Owen.
Are you on here? What is that? All right, it said Alex.
Yep.
And what's the last name? Sorry.
Holden,
How do you spell it?
H-O-L-D.
Okay, thank you. Emma, let's see. And this one? You go by Emma?
Mm-hmm.
Thanks. Michael? You go by Michael?
Yep.
Okay.
Okay, Andrew.
Andrew, you go by Andrew?
No, I'll go by Drew.
Drew, all right, thank you.
Caden.
And you go by Katie?
Yeah. I go
Okay. All right, let's go over. Please take a look at this one here. Who got this to work down? How did we rearrange it? Hands up if you got an arrangement that's going to be able to be broken down. What would we want to say?
5p squared plus p squared q squared minus 10 minus p. And you guys do this way.
Okay, and what did you get, please?
5 plus p squared.
Good.
P squared minus q.
There you go. Now, there is one also that I'm going to tell you tonight, because you're going to have some to go through and do for homework. If you ever get stuck, there's a website that you can go into. It's called Wolfram Alpha. It pretty much, there's a lot of work that it helps you to go through and do. One of the things that does get a little bit interesting at times is we act as if, because like there's not a 100% answer key there, that you can't possibly figure out how to do it. If you go to Wolfram Alpha, this computer is so slow. If you are on a high functioning computer, there we go. All right, so you can literally type in what you want it to do, and in most cases, it probably will do it. So like if I wanted it to factor something easy like, I don't know, x squared plus 5x plus 6, I type in that and I hit enter, and guess what pops up? Okay, so and it works on cell phones. They actually have an app that makes it even a little bit easier. But that's a way to check your answers on any of them if you get stuck. You go, oh, there was a GCF in there, maybe I didn't see. Or that answer means it probably looked like something different. Now, what I'd advise us to do for homework is slide over, please, to... I'll tell you this. On page 4, I would give, let's say maybe 2 through 20 even. On page 4, out of that group at the top, try 2 through 20 even on a separate sheet. But make sure you know how to recognize that factoring. It looks like there's a bunch that are grouping in there and GCFs. I think that's it. All right? The other thing is, make sure you have with you, I know not for today, make sure you have your Chromebooks with you next time. We need to show you how to go through and sign up for part of our online homework. Can I get the third and fourth row, please, to come on up, and we can see if I've got your names right. Make sure, guys, your calcs go back to where they're supposed to be. Thank you for study hall. Where are you? This? Can you go by Abby?
Yeah,
Perfect. Thank you.
Victoria Tudor.
And is that what you go by?
I go by Tori.
Tori. Okay, thank you. Hi.
Claudia.
And you go by Claudia?
Yeah.
Okay. What's your last name, bud? This one here, so you go by Zach? H or K? H, okay.
Madeline Tardino.
And what do you go by, honey?
Maddie.
D-D-Y-I-E?
Oh, I'm just.
Oh,
There's two.
okay. So what do you go by?
Maddie with a Y.
Okay, thank you.
William.
Okay. Hang on. Where are you? Are you on here, William? There you go. Yep.
Jonathan.
Jonathan, where are you, bud? Do you see it? What's your last name? Where's your last name? See? Okay. And what do you go by? Jonathan? John? Okay. J-O-N?
Yeah.
Okay.
Madeline Eugene.
All right, Madeline. And what do you go by?
Maddie.
Oh,
And I-E.
you're an I-E?
Yeah.
Okay. All right. I'll try to. Don't be mad if I call the wrong one.
James.
Yes. Willard? What do you go by? James?
Yeah, James.
Okay.
It's Allison.
Allison. And what do you go by? A-L-L-Y?
I-E.
A-L-L?
I-E.
Okay. Thank you.
Len.
Ren? I think that's how I have it. Yes. Ren? Okay,
Nahal?
okay.
Nahal.
Nahal works.
Aiden.
What is it?
Aiden.
Last name?
Show.
Oh, okay, and you go by Aiden?
Yeah.
Thank you, bud. Have a good day, guys.
You're supposed to log out of these.
Nope, it logs out when I close the class down. All right?